Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 11.3, Area of Polygons. So we'll be able to find the areas of rhombuses and kites, find angle measurements and regular polygons, and also find areas of regular polygons. You want to make sure you've got a good calculator to use because we're going to be talking about sine, cosine, and tangent again because we got some of those things going on. First thing is we're going to start off real easy. Area of a rhombus or kite with diagonals d1 and d2 is 1/2 times d1 times d2, okay? We say these are diagonals, not bases and heights, because it's a rhombus and a kite, okay? So again, area can be found by doing 1/2 d1 times d2. So we're going to try that here. For letter A, I would take 1/2 times 6 times 8, and I get 24 meters squared. For letter B, 1/2 times 10 times 7, I get 35 centimeters squared, okay? The next thing we're going to talk about is something called an apothem and central angle of a regular polygon. So an apothem is the distance from the center to any side, and it'll also be the height of the isosceles triangle, not to be confused with radius. This is not radius, okay? So like in this case, from P to Q is the apothem, the radius is PN, or you can even say the radius is PM, okay? Because PM and PN are touching the side of the circle, where the apothem is just going from the center to the side of a polygon inside. The central angle of a regular polygon can be found by dividing by 360 for the number of sides. So say this is a hexagon. That means it's 6-sided, so we would take 6 and divide it by 360, or 360 divided by 6. Okay, and that would tell you that each center angle is going to be 60 degrees. Okay, so we're going to try that here. It says in the diagram, ABCD is a regular pentagon, which means I've got 5 sides inscribed in circle F. So find the measure of each angle. The first thing we're going to look at is AFB. This is our center angle. So that means I'm going to be taking 360 and dividing that by my 5 sides. So that'll be 72 degrees, okay? AFG is exactly half of that. So I would take my 72, divide that by 2, I get 36 degrees, okay? And then GAF, think about GAF as here's G, here's A, here's F. This is 90 degrees. We just said AFG is 36, so I would just take that away from 180. So 180 minus the 90 degree minus 36 degrees is going to be 54 degrees. Super important that you can pull this little triangle from that inscribed polygon, because that's going to help us with the next set of questions. Here are some that you can try on your own. Let's maybe pause, try these on your own, and when you're ready to check, click play. All right, center, radius, apothem, and central angles. Let's start with our center. Our center is the letter P. We have our radius. You can choose 2 things here. You can say PX or PY segments. The apothem is PQ, and the central angle we would just say is angle XPY or YPX, okay? Now we want to find the measurement of these following angles. XPY, since it's the central angle, and this is a 4-sided figure, I would do 360 divided by 4, that's 90 degrees. XPQ is exactly half of that, so 90 divided by 2 gives me 45 degrees. And then PXQ, so again, here's our triangle, P, a Q, and an X. We just said that XPQ is 45, so up here in this corner is 45, which means the only leftover amount for PXQ is also 45 degrees, okay? Let's continue now and talk about how to find the area of a regular polygon. We're essentially going to be using this formula here, but we want to make sure we break down and understand what things are representing. A is going to be the length of the apothem. N is going to represent your number of sides, and S is the length of each side of that polygon. So in order to find the area of a regular polygon, that'll be, in this case, a lot of them will be inscribed in a circle. That's okay, we're just gonna recommend looking at that polygon, 1/2 times A times N times S, okay? Or A times N times S divided by 2, whatever you choose there. Let's go ahead now and try this question together. So it says a regular nonagon, which means 9 sides, has a radius of 4, and it's inscribed in a circle. Find the area of the nonagon, okay? So the first thing we want to find out here is the measurement of your central angle, which is KLJ, okay? That can be found by just taking 360, dividing it by 9, and we're gonna get 40, okay? Which now means I can find the measurement of 1/2 of that triangle. Let's say we focus on KLM. So the measurement of KLM would just be 40 divided by 2, which would be 20. So now what I'm going to do is I'm going to draw that picture of a triangle here, just so we can see where things are located. Here's my M, this is L, and this is K. Okay, this is 4 representing my radius, and I just said KLM is 20 degrees, which means LKM, if you want to find that one, you just do 90 plus 20, that's 1/10. This third last one has to be 70, okay? Now, step 3 is, because I want to find the area, I'm trying to use this formula, 1/2 A times NS, where A is your apothem, which I don't know that yet, so I'm gonna list that as letter A, from L to M, and I don't know my side length, so I'm gonna label this as, we'll say this is B for now, because that's technically not your full side length of your polygon, it'll just be half of that, okay? So one way we can find A, we're already given a side length, it is right next to that, so we can maybe do cosine, which would be adjacent over hypotenuse, okay? So that could be the cosine of that 20 degrees I just found is equal to adjacent A over hypotenuse 4. So essentially I'm multiplying 4 times the cosine of 20. So if I do that, 20 cosine times 4, A is approximately 3.76, okay? Once I find that, that means I know I can plug it in here, 3.76. I know the number of sides, nonagon, is 9, so now I just need to find S, okay? And again, I'm multiplying everything by 1/2. How I find S is I can find maybe now the sine of 20. So the sine of 20 would be opposite over hypotenuse, so sine of 20 could be letter B over hypotenuse 4. So essentially, again, multiplying 4 times the sine of 20. So 20 sine times 4, I'm getting about 1.37. So B is equal to 1.37. Now this is half of a side, so 2 times B is going to give me my full side. So 1.37 times 2, I'm getting 2.74. So now that I know my side, I can plug it into my formula here and then multiply everything together. So 1/2 times 3.76, A is your apothem, times 9 as your side, times 2.74, you should be getting about 46.36. So 46.36 is my final area, okay? This next one can be found the same way, except you're going to maybe notice that we can use something a little different here. It says you're decorating a top, so you're kind of thinking about this being a right angle, okay? I already know that the side length is 15, so here is 7.5, so guess what? We can use our Pythagorean theorem to find letter A, which is also the apothem. A squared plus 7.5 squared is equal to 19.6 squared. So A squared plus 56.25 equals 384.16, or a squared is equal to 327.91. So a would be equal to 18.10 roughly. So if what is the area we're covering? Good question, I'm so glad you asked. I'd love to tell you. 1/2 times a times n times s. So that's 1/2 times my apothem, 18.10, times n is the number of sides. This is a 1, 2, 3, 4, 5, 6, 7, 8 sided figure, and my side lengths are 15. Okay, as I'm multiplying that together, my total area comes to 1,086 inches squared. Okay. Last two, let's go ahead and pause these. I'll quickly go through them once you've tried them by yourself, but go ahead and see what you can come up with. All right, so both areas can be found by taking 1/2 times the apothem times the number of sides times the side length. Okay, so this first one, I don't know the side length yet, so I'm going to label this as maybe s, excuse the bell. So I'll have 6.5 squared plus s squared is equal to 8 squared. 6.5 is 42.25 plus s squared is equal to 64, or s squared is equal to 21.75. So that's going to be roughly about 4.66. But reminder, this is only half, so we're actually going to do double to get my full side length. So 2 times 4.66, I'm going to get s is actually equal to 9.32. So plugging that into my formula, we've got 1/2 times my apothem of 6.5 times 5, because it's a pentagon, times my side length of 9.32. I'm getting 151.45. Okay, for my last one, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sided figure. So again, I want to think about maybe these as like, here's my central angle. I know my side length is 7, so that's 3.5, but I'm not really given a lot of information. Okay, so what I could do here is start at the very beginning. I know if I find my central angle, I could divide it by the number of sides. So 360 divided by 10 is 36, which means this little guy in here is half of 36, which would give me 18 degrees. Okay, since I know that, this is going to help me find my radius, and this will be my apothem. So maybe I can do whatever from 18, opposite over adjacent for tangent. So let's do tangent of 18. So tangent 18 will be found if I do opposite 3.5 over adjacent A. Okay, because here's my right triangle. All right, essentially I'm going to be doing A times the tangent of 18 is equal to 3.5, or A can be found if I take 3.5 and divide it by my tangent of 18. Okay, that is going to give me about 3.5 over 0.3249, which A then would now be equal to 10.77. Okay, now I can probably do the let's see, I also need to find my radius, and that one is actually going to be found either by doing, can't do sine again, or tangent, but I can do sine opposite over hypotenuse. So the sine of 18 is equal to opposite 3.5 over hypotenuse r. So r times the sine of 18 is equal to 3.5. So I'm just essentially, r can be found by doing 3.5 divided by the sine of 18. Okay, so 18 sine is 0.390, 0.3090. So let's do 3.5 divided by 0.3090, getting about 11.32. Okay, so that means my radius should be 11.32 according to that. Finally, I'm going to have to then use all that information to help me figure out my radius, which now I don't even know why I did radius. that would be how you could find the radius, but we didn't need it because to find area, you just need 1/2 of your apothem, which is 10.77, times the number of sides. We decided this was a 10-sided figure, times the length of the side, which is 7. So I did all that extra work for nothing. Yay me. 376.95 should be your final area for that one. Okay? Hopefully this video helped you. I know it's a lot to think about, but as long as you're comfortable knowing the apothem, using sine, cosine, or tangent to help you find the number of sides or the side lengths, you should be good to go there. Thanks for tuning in, Geometry. Have a great day, and we'll catch you next time. Bye.